Last class we have studied about the electrostatic potential due to electric dipole and system of charges. Okay. Today we are discussing about equipotential surfaces. Clear? So, uh, chapter 2, lecture 3. Electrostatic potential and capacitance. The chapter is electrostatic potential and capacitance. Today's topic is equipotential surfaces. Equipotential surface. What equipotential surface? The meaning of this word is equi means same. Same what? Potential. So, what is same potential? Already we know the expression potential is equal to 1 by 4 pi epsilon naught source charge divided by distance between the source charge and the point where we have to find the electric potential. Okay, so let us consider this is plus q charge, this is plus q charge. Okay, source charge at a distance r, its potential is how much? V is equal to 1 by 4 pi 1 by 4 pi epsilon naught q by r. Okay, the same distance r, let us consider this is a point in this direction. This is distance r and this is point B. Okay, from this source here the potential is also 1 by 4 pi epsilon naught q by r. Similarly, we can find same potential at a distance r. We can also find same potential at a distance r here. So if we imagine a surface like this, okay, at a distance r, okay, at a distance r, then every point of this surface will have the same electric potential. Okay, at a distance r, the potential at every point on this surface is same, that is equal. Okay, therefore this surface is called equipotential surfaces. Clear? This surface is called equipotential surfaces. So we can write the surface at which potential is equal all over the is equal at any point all over the surface. Okay, this is what equipotential surface. Clear? Okay. Now there are some properties of equipotential surfaces. Those are: there is no need of work done to bring a charge from one point of equipotential surface to the other point of equipotential surfaces. Let us consider this is A point. We already considered this is A point. Let us consider this is B point. Okay, we have to bring a charge plus Q from this point to this. Clear? Okay, here the potential is this much, and this is all here also potential is same 1 by 4 pi epsilon naught q by r. Okay, now we have to bring this charge from this point to this point. Clear? So Here to here, work done is how much? Work done. We need what? Work done. We need work done. Work done is equal to how much? Work done is equal to work done by surge is equal to potential. We know that. Now, work done is equal to Q into V. Okay. Okay. Here, the surge is Q, and in this point, potential is how much? V. Okay. There is some potential stored as potential energy stored as this point. Okay. How much potential is there? Okay. Here is potential is how much? Let us consider this is this potential is here work done is how much? Q into V. Okay. Now these bring to this point. Therefore, the work done W2 is equal to Q into V. Same. Therefore, work done W2 minus W1 is equal to how much? 0. If W2 minus W1 is equal to 0, that is what? No need to do work to bring this charge from this point to this. Okay? So, write down property. There is no need to do work to the surface from one point to other in equipotential surface. Okay, there is no need to do work to move the point, move the surge from one point to other in a equipotential surface. This is one of the property. Okay, this is surge Q. Therefore, here the potential we can find potential here. If we see electric field, okay, electric field at any point of the equipotential surface is perpendicular on the surface. That is, this is equipotential surface, so this will be the direction of electric field. We know that this is charge, so this is electric field on the equipotential surface. That is what? This is 90 degree. We can also find here. Here this is what? This is tangent. We can draw tangent. Here this is tangent. This is the direction of what? Electric field. We know that from any charge, positive charge, the electric field lines are radially outward. So this is the direction of electric field, which is perpendicular to the equipotential surface. Okay, this is another point. Write down. At any point on the equipotential surface, at any point on the equipotential surface, electric field is perpendicular on the surface. Perpendicular on the surface. Clear? Okay. This is one property. One. Okay. Next property is two or more equipotential surface two or more equipotential surface never intersect. Okay, we can find here. We know that here the distances r. Okay, due to this r, the potential is how much? V 1 by 4 pi epsilon naught q by r. R determines the potential. Okay, now we can find another equipotential for surfaces like this. Okay, this what will be its distance? R1. This is, if you consider x, then this is how much? R minus x. So its potential is lower than this potential. Right? Okay. Every point on these surfaces, we can find the potential is same. Okay. Let us consider this is V1, V1, V1. Every point potential is how much? V1, which is always less than this potential V. Okay. Therefore, this surface cannot intersect this surface. Clear? Fine. These are the properties of equipotential surfaces. Okay. Now we are going to discuss about the relationship between the electrostatic potential and electric field. Okay. Electrostatic potential and electric field. Okay, we have to find the relation between electrostatic potential and electric field. Okay. Okay, let us consider a situation. Let us consider this is Q cells. Okay. Okay, let us, this is point A, this is point B. Clear? This is infinity. Okay. We have to, this is plus Q cells. Let us consider this is source charge. Source charge. Okay. This is what? Source charge. Now another such plus Q, we apply force to bring this plus Q charge from this to this. Let us consider this is dx displacement. Okay, therefore work done to bring plus Q charge plus Q test charge from position B to position A. Okay, work done B to A is equal to force, external force. Okay, we just apply F external towards this direction. Force is applied to force is applied to bring the charge from B to A. Therefore this dx is in this direction, for F external force is in this direction. Therefore work done to bring the charge external force into dx displacement. Clear? Now this is Q charge, this is Q charge. Therefore electrostatic force F is applicable here. So F, direction of F is this. Okay, how much external force we have to apply? Same as the force by electrostatic. Okay, due to these charges. Therefore, we can write work done to bring the charge from B to A is minus Fe. Why we have written minus Fe? Because F external is equal to opposite to the electrostatic force. Therefore, F is minus Fe. Minus Fe is here. So, dx. Okay, clear? Again, we know that what? F is equal to QE. We know that F is equal to what? QE. So, this force is how much? QE dx. Okay, this is equation number 1. Clear? Again, we know that. Again, we know that from the definition of potential, dV is equal to how much? dW by Q. We know it from definition. From definition, we can write what? dV is equal to dW by Q. Therefore, we can write dW is equal to dV into Q. Okay, here the potential is something V1, this is something V2. Therefore, V2 minus V1 is equal to how much? dV. Okay, so difference of potential is there. So dW B to A, we can write dW B to A is equal to dV into Q. This is equation number 2. Clear? Okay, so from these equations, from the both equation, we can write from the equation 1 and 2, we can write what? So this is work done to bring the charge from infinity from B to A. This is also work done to bring the charge from B to A. So minus QE dx is equal to dVQ. Okay, so E is equal to QQ cancel out, dV by dx. Okay, we can write minus here. So electric field is negative gradient of potential. Okay, what is this? Electric field is negative gradient of potential. Electric field is negative gradient of potential. Okay, this is the relationship between electric field and potential. Now the next topic is what? Potential energy due to system of charges. Okay, today we will discuss about the two-body system. Okay, let us consider there are two charges. For two-charge system, okay, let us consider this is free space, no charge is there in this space. Okay, now let us exert positive Q1 charge at infinity from this space. Clear? Now we have to move this charge from this place to this place. Okay, Now we have to move the plus Q1 search from this position to this. That is what? This is at infinity. This is also infinity because there is no search. Clear? Therefore, we need not to do any work to bring this search Q1 from infinity to position A. Clear? So, work done to bring this search from infinity to this position A is W1 and is equal to 0. Clear? Now Q1 is at what position? Q1 is at this position. Now another search, let us consider Q2 is at infinity. Okay. Now we will bring this search from this position to somewhere in the space here at position B. We bring this Q2 search from this position to this position. Clear? This is how much work is required, W2. How much W2 is. Okay. Now this search Q1 is here. Therefore, it creates a field around the search Q1. In Q1, that is, there is a field by what? By Q1, around Q1. Clear? If we bring this search from infinity to this point, that is inside this field of this Q1 search, then we have to apply force. We have to apply F external to bring this search from infinity to this position. Clear? So how much force we have to? Okay, F external should be applied. Now we'll think about another thing. Let this position B2. Let this position B2 is at a distance R12 from the point A. B position is at a distance R12 from A. Therefore, there will exist some potential at point B due to search Q1. How much potential will be there in this point? That will be equal to, potential will be equal to 1 by 4 pi epsilon naught. Okay. Search test search, that is plus Q1 divided by distance, that is R12. This is the potential at point B. Okay. Due to what? Due to search Q1. Clear? So here the work done we have to find. Therefore, we again know that potential is work done by search. Okay, then work done is equal to how much? Q into V. Clear? So we brought this Q2 charge. We brought this Q2 charge to the point B. Clear? So what will be the charge here? That will be the charge Q2. How much Q2 charge experience potential? This amount is this much. Therefore, it will be Q2 into 1 by 4 pi epsilon naught Q1 by R12. This is work done. Clear? So we have to do how much work done? Q2 into 1 by 4 pi epsilon naught Q1 by R12 force is required. Okay, what we are searching for? Two search system only. Therefore, what will be the total work done? Total work done will be W1 plus W2. That much of work done will be stored as potential energy in the system. Clear? So we can write. Let us consider. A point surge plus Q1 is at infinity. Okay, we have to move the surge from infinity to point A. Since there is no any electric field, therefore no work done is required to move. No work done is required. That is what? That is work done W1 is equal to 0. Clear? Okay. Now to bring the surge, Q1 to bring the surge Q1 from infinity to, not Q1, Q2, sorry, Q2 from infinity to point B. Now to bring the surge Q2 from infinity to point B, we have to apply force against the electrostatic force between Q1 and Q2. Okay, now what? We have to apply force against the electrostatic force between Q1 and Q2. Clear? Therefore, work done in bringing the surge Q2 is, how much work done we have to do is W2 is equal to this much. Okay, so W2 is equal to how much? Potential at point what? B and potential at point B and surge Q2. Okay, the potential at B is how much? Potential at point B is 1 by 4 pi epsilon naught due to Q1 surge. Therefore Q1 divided by distance between the point B and surge Q1 is R12. Okay, R12 into Q2. Clear? This is the work done required to bring the surge from infinity to the point B. Now this much work done, that is W1 is 0, okay, and W2, therefore the total work done, W is equal to W1 plus W2, so 0 plus 1 by 4 pi epsilon naught Q1 Q2 by R1 2. this work done is stored as, this work done is stored as potential energy in the system. Clear? This much, that is U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R1. Here, this is the potential energy. Three body system, what we have to do? Clear? Already we have done for two body system. Okay, Q1 and Q2. Clear? This is the potential energy. Okay. Now we brought another charge. Let us consider Q3. Q3 charge is at infinity. At infinity, Q3 charge is there. So we have to bring this charge from this position to this position C. If we have to bring this charge from infinity to this position, that is what? That is what? Okay, listen. First of all, for this, for three body system or three charge system, first of all, before like the previous topic, just we have to bring the Q1 charge from infinity to that place. No need of work done. Therefore, W1 is 0. We know that. Write down like that. Next, another charge Q2 is being same to same. You have to place that. Okay? And work done is this. Clear? For two body system. Now, we are going to bring another charge Q3 from infinity to the point C, which is at a distance. This is how much? This is, let us consider R1. This is 0.3. This is 1.3. Distinguishable. Okay. This is how much? What? How much? R13. And then again, B is at a distance R. B is two position. W2 we found that two position. Therefore, 2, 3 is distance. Clear? Now, what we have to do? We have to bring this Q charge from this position to this position. Then, what we have to do? We have to do work against the field or against the force of Q1 and Q3. Simultaneously, we have also applied force against the force by Q3 and Q2, because Q2 charge is at this position. Okay, already we brought the Q2 from this position to this position. The Q2 is here and Q1 is here. Therefore, we have to apply the force against the force between what? Q3 and Q2 and Q1 and Q3. Okay, therefore, we have to find the potential at point 3, at point C, due to the Q1 charge and again due to the Q2 charge. Clear? Therefore, we can find potential at 3 due to point charge 1 is equal to how much? 1 by 4 pi epsilon naught. What is the charge? Q1. What is the distance between Q1 and Q3? That is R13. Okay. Similarly, potential at 3 due to the point charge Q2 is equal to V23. We can write 1 by 4 pi epsilon naught. What is the charge? Q2. And what is the distance between the Q2 and Q3? That is R23. Okay. So V31 is this, V32 is this. Okay, now we can find work done to bring the search Qt. Now write down to this point from the initial stage, initial line. Okay, after that we will start for 3 search system. Clear? We have to write down for the 2 search system initially. After that continue from this point. Now we have to bring plus Qt search from infinity to point C at a distance R13 from point A and R23 from point B. Okay, clear? Now total potential at point C is V3. You can write V3 is equal to 1 by 4 pi epsilon naught Q1 by this much R13, okay, plus Q2 by R23. This is the potential at point 3. Clear? At point C. Therefore work done required to bring the search at required to bring the search from infinity to C is how much? Work done W3 is equal to P potential V3 at C into Q3. Okay, therefore which value is how much? Okay, we can write it. No. W2 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12. Okay, we can erase right now. Okay, potential at C is how much? 1 by 4 pi epsilon naught Q1 by R13 plus 1 by 4. We can write Q2 by R2, Q2 by R23 into Q3. Therefore 1 by 4 pi epsilon naught Q1 by R13 plus Q2 by Q1 Q2 plus Q2 Q3 by R23. This is the work done W3. Now the total work done. Now total work done W is equal to W1 plus W2 plus W3. We know that W1 is 0, W2 is 1 by 4 pi epsilon naught, which was the result for the previous case, Q1 Q2 by R12 plus how much? 1 by 4 pi epsilon naught Q1 plus 1 by 4 pi epsilon naught Q1 Q2 by R12 13. Sorry, this should be R. This is Q3, right? Q3. Q1 Q3 Q1 Q3 Q1 Q3 plus Q2 Q3 R1 R2 3. Okay, this much of work done is stored as potential energy. This work done is stored as potential energy. That is U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 plus Q2 Q3 by Q1 Q3 by R13 plus Q2 Q3 by R23. This is the total potential. Clear? This is the total potential energy stored in the three-surge system. Clear? Okay. Thank you.